With due respect, my name is Sopan Tudu, and today I'm going to talk about the topic signals and its classifications. So let's get into it. Now, what exactly is a system and signals? Well, for first, signals is something that can be interpreted as information wearing a mathematical outfit. Now, it's a function that tells us something about the world. Could be voltage in a wire, sound from a speaker, brightness of a pixel, and you name it. Now, we've got two main types of breeds of signals. Well, the first one is continuous time signal, and the second is discrete time signal. Now, what is continuous time signal? Well, it is smooth, defined at every instant like a sine wave just cruising along. Now, for discrete time signal, only exists at specific moments, like a song sampled into individual beats. For example, xt equals sine 2 pi 50t. Well, in simple terms, it means continuous signal with a 50 Hz sine wave. Now for xn equals cos pi n to the by 4. So what does that mean? It's a discrete time signal with a cosine sequence. Now this was basically the main type, but for the different types and classifications that we are going to get along with in the next time, we will see deterministic and non-deterministic signals as the first classification. Now, what exactly is it? A deterministic signal is likely that one friend that always orders the same food. You know exactly what you're going to get. And now, this is predictable because in simple terms, a deterministic signal is a signal that can be exactly described by a mathematical expression, and well, it's very predictable. Now, for example, we can say xt equals 5 sine 2 pi 100t. Now, well, it simply means it's a sinusoidal signal with amplitude 5 and a frequency of 100 Hz. And for non-deterministic signal, it's like that one chaotic friend who says surprise me and might order pineapple pizza. So it simply means it's unpredictable and it's more of a random noise in electronics or maybe the stocks on the stock market. We cannot predict when and what will be the next move for a non-deterministic signal. Now, we sometimes write it as xt equals mt plus nt. Now, mt is simply which is predictable. As for nt, it's the unpredictable one, the chaotic friend. The second type and classification, periodic and non-periodic signals. Well, a periodic signal is like your alarm clock shows up exactly when expected over and over. It's more like a pendulum. For example, sine 2 pi 100t is 2 pi t, not 100t, is basically period equals 1 second. As for non-periodic signal, it's exactly the opposite. We do not know when it will happen once again. Let's consider an event. Example being me going to the gym. It happened once, but I may not know when I'm going next time. So yes, it's unpredictable and it's does not happens over a over same time period. Now, for example, e to the power minus t ut. It simply fades and never comes back. It's more of an exponential decay. Now, symmetric and asymmetric signals is the third classification we will get into. Now, it is exactly mirror symmetry. Every signal minus xt equals x minus t are perfect mirrors. Cosine wave, t square. If you have to fold them in half at t equals 0, they match exactly. And for asymmetric signals, minus xt equals minus x minus t, or like the one side flipped upside down. Sine wave, straight line through origin. Simply that. It's basically about mirror symmetry. Now, for the next classification, energy and power signals. Well, energy signals have a finite energy. And yes, it means a finite amount of juice. It eventually dies out, just like petroleum and coal that will one day get exhausted from the core of source of the earth. Like e to the power minus t equals ut. Now, power signal, infinite energy but constant average power, like a never-ending sine wave. Energy equals total work done and power equals how much work per unit time. Now, for the last classification that we'll get into, causal versus non-causal signals. And well, its causal signal is realistic. It doesn't exist before time zero, like a live stream, or maybe a cricket match that you will see on Hotstar, or maybe any other app, and you're seeing directly on live. It happens exactly at the right moment, and you cannot see the future. Example e to the power minus t ut. And as for a non-causal signal, it's like watching a recorded video, just like you are watching this video right now. You can even see stuff before now by seeking the video from on a different timestamp. And well, for this example, it's basically e to the power t, defined for all t. Now, yes, closing this and tying this together, we understand. So signals can be predictable or chaotic, looping or one-off, mirrored or odd, falling and fading or endless, realistic or time traveling. Knowing this type of signals helps us design, analyze, and fix systems, whether it's audio recording and processing, image compression, or that dodgy Wi Fi in the room. Thank you.